Hello and welcome to Math 139 Review. Today we're going to talk about topics that will be covered on Exam 3, which will take place tonight. So quick reminder about the exam. Exam will be online through Brightspace. And it'll start 8 p.m. tonight and end at 8 p.m. tomorrow. And I recommend starting early, and I don't want you to lock out, so I recommend actually starting before 7 p.m. Tomorrow. So for the exam, you'll be allowed to use scratch paper, pencils, pens, calculators, but you will not be allowed to use your textbook nor any of the digital resources, any of the handouts that we had throughout the course. So let's look at some of the contents. So we can think about specific topics that we covered in the course, which includes angles, area, perimeter, surface area, volume, and some more topics about circles. And we have some scope ways of actually looking into these topics, and those will be about measurements. So in the measurement, we have key ideas such as the unit of measurement, standard units, and the idea that the measurements are approximate, and also that the measurement can be divided and added, called additivity. So let's start with some of the key ideas behind measurements. These are the topics that we talked about before exam 2, but it'll be a good reminder because it helps us understand what we need to know as instructors. So the first concept was that when measuring mathematical attributes, we count the number of units. So think about having a ruler or protractor. When you're measuring some length, say this amount, we would count 1 inch, 2 inch, 3 inches because we see 3 of the unit inches measuring the length here. Another concept of measurement is that we use standard units. So for length, we have things like centimeters, meters, inches, feet, yard. Area, we have square centimeters, square meters, square inches, square feet, and so on. And for volume, we use cubic centimeters, cubic meters, cubic inches, cubic feet, but sometimes we use liters, milliliters, gallons, and so on. Another idea that we mentioned was that measurements are always approximate. So it doesn't make sense to say that your height is 5 feet. You can't say it is exactly 5 feet. You can say it is about 5 feet. And finally, the measurements can be added or subtracted, and we use this idea so far. So for example, if you have an object, a figure like this, we would try and would like to understand the area, which is a mathematical attribute. We would try to find the area of this rectangle on the left first, try to figure out the area of the rectangle on the right, and you can simply just add the area to figure out the total area. That was one of the key ideas that we use in the course. So using these key ideas, let's look at some of the specific topics that we talked about in the course. Starting with angles. So number one, we use the angle using protractors. So that is about how we measure it. In terms of the units, the standard unit for angles in elementary school is degrees. But sometimes we need a finer units, and in that case, we can introduce smaller units such as minutes and seconds. Here, the convention is that 60 minute is 1 degree, and by the same principle, 60 second is 1 minute. So, for example, if you want to add 143 degree 16 minutes to 16 degree 55 minutes, you would combine degrees, you would combine minutes. If you combine degrees, you get 159 degree. If you combine minutes, knowing that 60 minute would be 1 degree, Just combining minutes gives you 1 degree and 11 minutes. So the total will be 160 degree and 11 minutes. So how is that actually showing up in the problems? So if you look at the review problem number 3, so the problem asks you to figure out which triangles are congruent to each other, knowing 2 of the angles inside a triangle. So the first step in understanding that problem is to figure out the other angle if 2 angles of a triangle are given. I'm looking at triangle number 1, and that one has angle 70 degree and 45 degree and 50 minutes. So the sum of 70 and 45 degree and 50 minute gives me 115 degree and 50 minutes. And I know the sum of angles inside a triangle should be 180 degrees. So by simply subtracting 115 degree and 50 minutes from 180 degree, that gives me 64 degree and 10 minutes. So that is the third angle. And then once I have the third angle, I can just compare the angles and figure out which of them are congruent to each other. So in this review problem, triangle 1 and 2 have angles 70 degree, 64 degree and 10 minutes, 45 degree and 50 minutes, so they are congruent, whereas triangle number 3 is not congruent to any of them. So let's look at the area now. So area can be described as the amount of space enclosed inside a 2D figure. So if I have a heart shape, the area of this heart shape will be in this pink, the space inside this heart shape. So what are the units? So often we compute the area by counting the number of units, usually in squares. So if you draw this kind of grid, all I have to do is just count the number of squares that is inside the figure. And in that perspective, we can even describe the area this way. The area is the number of unit squares that can fit into a figure. So that is more of a measurement perspective of the area. The standard units for the area is centimeter squared, meter squared, square inches, square feet, square yard. And one question that comes out in this particular flavor is, can you actually convert one unit to another? So for example, if I have square centimeter, which is just centimeter times centimeter, and we'd like to convert that to millimeter times millimeter, first thing that we want to remind young students are which units are bigger units. Obviously, centimeters are bigger than millimeters. So if you're measuring the same amount of length or area, you expect the numbers will be bigger if you're measuring in square millimeters. So that's one of the things that we did in the homework problems. X amount of truckload compared to Y and a wheelbarrow full. That is to train you in understanding those kind of concepts. But since we're using metric units and standard units, we know there is a conversion factor. So between centimeters to millimeter, all you have to do is multiply 10. Again, since I have 2 of them, I also have to look at converting centimeter to millimeters, so that's another times 10. So all you have to do to convert square centimeters to square millimeter is to multiply 100. So in that spirit, 14 square centimeter is the same thing as 1400 square millimeters. So continuing on the area, we also have to talk about the additivity, that any measurement can be divided or multiplied or added. So let's look at this parallelogram. So this parallelogram has base, and height. And as I said, we can always move them, cut and paste them, or even glue some of the new faces to figure out the area. And one thing we did with the parallelogram is to move one of the triangle on the right to the left like this, and convert this into a rectangle. And we figured out the area formula just by doing that the area of a parallelogram is just base times height. Same thing with a triangle. We start with a parallelogram and we can just divide that into two pieces, two identical pieces, and that gives you a triangle with base and also the height. And by looking at that, we figured out that the area of a triangle should be half of that of the parallelogram. Finally, this is something that we're going to talk about later on, that if you start with a circle, we can divide them into pieces and reassemble it in a way that resembles a parallelogram. Well, if you do that, that'll be the half of the circumference, approximately, and the height is also approximately the radius. And from that, we were able to figure out the area for a circle should be pi r squared. Now let's talk about perimeter, which is another measurement we can do on 2D objects. So the perimeter can be thought as the length of the outline in a shape. And usually you would use this kind of square complex to help children understand the concept of perimeter and area. So in this case, what are the units? Well, we can compute the perimeter by just simply counting the number of sides. And in this case, you can describe the perimeter as the number of unit side length that can fit into a figure, or the boundary. Now, standard units, because this is length, will be in centimeters, meters, inches, feet, yard, or any unit of length. And another question we can ask, how is this related to the area? How can you actually increase the perimeter, decrease the perimeter? So we start with this kind of oval shape. Our intuition says that if you increase the size, that is to increase the area, obviously the perimeter grows as well. But not always. For example, with this example, if you add another square right there, the area increases by the unit square. But you can realize the perimeter actually decreases in this case. So the perimeter and the area are not related in general. So let's see how additivity helps us figure out the area and the perimeter. So I'm looking at the review problem number 7. So this shape, as you can see, is composed of a rectangle and a semisphere on top. And the dimension for this figure is 6 by 10. Now, since I have a semisphere on top, I know the diameter for this semisphere is 6, which means the radius, if you try to draw it, will be 3. So knowing that, I know that this rectangle has dimension 6 by 7, and I have a semisphere whose radius is 3. So knowing that, let's figure out the area. Well, the area was just pi r squared, and it's just half of it, so I do 9 pi over 2. That's how I got 9 pi over 2. The rectangle has area 7 times 6, so that's 42. So the total area is 9 pi over 2 plus 42. What about the perimeter? Well, I have side 7 right here, side length 6 on the bottom, 7 on the other side, and I have half of the circumference. The diameter is 6, so I do 6 times pi. It's just half of it, so I do just divide that by 2, which gives me 20 plus 3 pi. So that I'm using the additivity of the perimeter, additivity of the area to figure out the area and the perimeter of the shape. Now let's talk about the volume and the surface area now, which is a 3D analog of the area and the perimeter. So the volume, you can think of it as the amount of space enclosed in a 3D figure. So if I have this kind of box, I can imagine how much stuff I can stuff into a box. So what are the units? So often we compute the area by counting the number of unit cubes. So you can think about this kind of orange cube and imagine how many orange cubes you can fit into this box. And in that way, you can describe the volume as the number of unit cubes that can fit into a figure. Standard units are cubic centimeters, cubic meters, cubic inches, cubic feet, cubic yard. And again, we can ask questions involving, can you actually convert one unit to another unit, which uses the same idea. Now with the perimeter, with the surface area, you can think of it as the area of the surrounding surface. So for a box, you have 6 faces. You really just have to compute the area of each of the faces and add them up. Again, what are the units? Well, you just have to count the number of unit squares on each faces and add them up. And because this is area, the standard units would be things like square centimeters, square meters, square inches, square feet, square yards, and so on. So let's look at some examples here. Often we use this kind of cube complex to help children understand the concept of volume and surface area. So for the volume, you can find the volume by counting the number of unit cubes, whereas for the surface area, you'll be finding the number of unit squares on the face. So if you actually count the number of cubes in this figure, you'll realize you have 3 plus 1 plus 1. So I have 5 cubes. Whereas for the surface area, you'd have 22 unit squares. That'll be the surface area. And we will play this kind of game with different cube complexes, and we would convince them to actually build this kind of rectangular prism. And using the same strategy, I can count the number of cubes on the bottom level, and then the second level, and then to the top level. And by doing so, they develop a strategy of finding the volume by counting the number of cubes on each layer and multiplying that by the number of layers, that is, the height, which gives us this nice formula, the volume being the length times width times height for any box. So let's develop this intuition into the volume and surface area for a prism in general. So for a prism, in this case is a rectangular prism again, I can think of how many base I can stack up, which gives me the volume being the base area times height. By the way, this also works for a cylinder too. Whereas for the surface area, we could try to do something similar, but a better way to look at it is to look at its net. And you'll see once you actually open up a net, I see 2 bases, and then I have lateral faces. And for lateral faces, if you look at the length of one of the sides, you realize that it is the same thing as the perimeter of the base. So the surface area, I can figure that one out by finding the base area, multiplying that by 2 because I have 2 bases. Find the perimeter of the base and multiply that by the height, which is the rectangle that I'm seeing right here. And this is the area of the rectangle right here. So finally, some more concepts about circles. So some terminology that I want to set up. So let's say you have a circle. If I connect 2 points, it's called a chord. Now, if the chord goes through the center point, or simply the center, we call this the diameter. And once you have diameter, the perimeter of a circle is called circumference, and we can define the ratio of circumference to diameter and call it pi, which is about 3.14. Now we say pi is about 3.14, but this isn't really a measurement. This is a mathematical constant. So once you have a circle, you can also look at a partial circle. So this orange area is called the sector. And if it's just half of a circle, we call it semicircle. If it's a quarter of a circle, we call it quarter circle. Also, once you have, so part of the circumference, so for example, I'm going to color this with red. So part of a circumference is called an arc, represented by the central angle. And now whenever you have an arc, so if I just look at 2 points, I always get a pair of arcs. So the arc that is greater than 180 degrees is called major arc. An arc that is less than 180 degrees is called minor arc. And arcs are represented by the central angle. How do I find the area of a sector and the area of the arc length? Well, the length of the arc. Well, for the area, you will look at the ratio of the central angle to 360 degree. So if this were, say, 75 degree, then the area of the sector will be simply 75 degree over 360 degree times the area of the circle. Similarly, for the arc length, if I'm looking at the arc, all I have to do is just look at the area, so 75 degree over 360 degree times the circumference of the original circle, and that gives me the arc length. So here's a summary of the review today. We talked about how to represent angles using degrees, minutes, and seconds. Minutes being 60 seconds and 1 degree being 60 minutes. We also talked about finding the area of triangle, parallelogram, and circle, finding the area of some composite figures, finding the perimeter and area by simply counting the number of sides and number of squares. We also talked, for 3D figures, we talked about how to find the surface area and volume of a prism and a cylinder. And we talked about some of the concepts involving circles. So some of the formulas: parallelogram, you have area being base times height. Triangle is just half of that, so area is half times base times height. For a circle, the area is pi r squared. Volume for a prism or a cylinder, all you have to do is find the area of the base and multiply that by the height to find the volume. Whereas for the surface area, you had to do 2 times the base area plus base perimeter times the height. Thank you for watching this video, and good luck with the exam tonight. Bye.